Good morning, everyone. It's a real pleasure to be here and to be leading the Digital Twin Technologies panel. My name is Carlin Levander. I am Vice President for Global Strategy at Rice University and also the Carlin Professor in the Humanities, and also author of a book out this week that speaks to many of the issues we're wrestling with today called Invent Ed: How an American Tradition of Invention Can Transform College Today. And it's very much about creativity, the future of higher education, and of course, the future of innovation in our country, focused on AI. And so it's a real pleasure to introduce our panelists. Our first panelist will be zooming in, and this is Nicolas Waern. He's the CEO and founder of LifeATLAS. I'm going to introduce everyone so that then we can just move to the discussion. And then we will be followed by a presentation by Andy Lin, who's VP for Strategy and CTO at Mark III. And then finally, Deanne Carlin is going to be speaking. She is the Director of Technology at Southwest Airlines. So let's go ahead and get started with Nicolas.
Yes. Okay. So probably 1 minute is gone. My name is Nicolas Waern. I'm the founder CEO of LifeATLAS and also Winio. Vision is a world where people and AI are used to create lasting impact 99% faster together. And it's not just LLMs, it's all the different AI flavors, knowledge, data that we can get to our disposal. I've been prophesizing about LQMs, large quantitative models, because I've been working with digital twins now for 7 years. And my background is in innovation and strategy, international management and IT management. I had this idea that I wanted to solve all problems in the world that operate in all countries in the world 25 years ago, which basically means that you're a little bit crazy and you say yes to a lot of different things. I've been guest lecturing at Oxford University, advisory boards, thought leadership, also an entrepreneur, and now working with personal digital twins and bringing richer context and knowledge as well as data more to knowledge-based, knowledge graph foundations. And again, not just LLMs. What I see from a global perspective, again, having said yes to almost everything, is that we have this reality, which is a standard that we all use, but we tend to forget about it. So the methodology I created is basically called zoom out to zoom in, and it's not wax on or wax off. It's how do we can get to an outcome in this area of the planet. It could be in a large scale, small scale, and using people as well as AI to get there. What we see here is when you zoom out and you see 200,000 cell towers, bringing in data from 6 different systems, pulling this together through real-time data, and then you can use physics-based aspects on top of it, but also people collaborating together. This is very much the same. We zoom out and we zoom into Seattle. This is a couple of airplanes here, I think, where we bring in APIs from this part of the world, and we can visualize things and we create a shared reality using reality as a boundary-spanning object, so we can get people, systems, real-time data, physics-based models, and different people can work together because, again, they have a shared reality. More of the same. Again, this methodology is equipped to zoom out. You see 7,500 Starlink satellites. I'm working with this. I have a presentation later this week with Rebuilding Ukraine, because the idea is to try something virtually first based on contextual rich data from reality. You can potentially use LLMs, but then you fine-tune it by actually using physics-based models. What we see here is, again, the combination, or I would say the similarities between what I've been working with, which is smart buildings, smart cities, energies, national digital twins, and then eventually global digital twins, is that buildings share a very similar DNA to people, in the sense that if you look at just the floor plan 40 years ago or the DNA 40 years ago, we don't capture life cycle, we don't capture lifestyle, we need more context. And I believe that the data that we're using today in most industries is fragmented. It's not necessarily representative of the reality that we're trying to improve. And I've been focusing a lot on hospitals, interoperability. And when a family member of mine got breast cancer a couple of years ago, I went neck deep into building platforms for personal digital twins as well. Epigenetics is coming on strong. This is what it looks like. We can share information, collect information in one place instead of having it fragmented in different places. It's a first, what we call it first principle, where you go to where the data actually originates, edge intelligence, confidential compute, decentralized computing, so people actually are in control of their own data. Once you have this in a decentralized health journal, sending it to digital hospitals to run through simulations 10,000 times that otherwise would take years is what's happening right now in China and other places. We're doing this also for horses because it's the same problem with fragmentation, using exactly the same thing for data center orchestration. You zoom out in an area of the planet, you zoom out to the entire planet, you zoom in, and then you layer what will be there. You work with people, getting their knowledge, and also use physics-based digital twins with the likes of NVIDIA Omniverse, ANSYS, Isaac Sim, robotics, physical AI, to train things in that very reality where you get people, data, systems to actually collaborate together. This needs a methodology. As we heard from the previous speakers, it needs to be repeatable, it needs to be scientific, and this is really where a methodology needs to come in. I've been basing this on something called extreme collaboration, which is the NASA JPL one, where they put, I think it was 20 people in one room with the right information, decision-making capabilities. What took 9 months, they went down to 9 hours. This was before AI and LLMs. And it was just getting people to actually work together on a shared reality. Done in 95. So if we can make decisions 99% faster by putting the right people in the same room, what if this room, aka digital twins, a digital copy of something that either has happened, is happening, or will happen, getting people around that, not just looking at knowledge graphs or code, but actually using reality as the boundary spanning object, that's what I see is really interesting. So what I advocate for is not just getting stuck with data, but actually starting with the outcome and impact, understanding the insight needed from people, systems, and AI, the actions that we need to take. Do we have this information and do we have this data? Because otherwise, when you start with data, you tend to forget about the actual outcome. And again, knowledge transfer today can be done through multi-agent generative systems. Need to be very, very careful. I think the ones at the cutting edge, they recognize that LLMs are 8 to 12% of a solution. The other parts are physics-based aspects, business rules. It's humans also like on the loop, humans in control, but AI in the loops. And this is what I think we can, get ahead of us next year. We'll see that it's less LLMs, it's more LQMs, large quantity models, small quantity models, decentralized, compute, and we can work with people, systems, and AI using reality as the boundary spanning object. I love to connect with people. One of the coolest startups, scale-ups that I've been working with right now, they can do GPU optimization, 50x faster execution, 97, 88% energy reduction, and right now making a 2018 data center perform like the 2026 one. This, I think, combined with AI and everything else, would just accelerate these research advances in cancer and anything and everything that everyone is doing today. So that's it for me.
Thank you so much, Nicolas. Really, you're really great. And now we are going to turn to Andy.
Hey, everyone. I'm Andy Lin, VP Strategy, CTO Mark III. We're the Video League partner. I'm going to talk a little bit about digital twins, specifically in healthcare, and sort of the future smart hospitals in 7 minutes. So, next slide. So, this is a very simple math problem. It's Monday morning. And I use this analogy a lot. Like, this is much more fundamental in a certain sense. Why go through the trouble of building a digital twin to simulate the real world when you can sort of do something in the real world today? Probably a lot easier, right? Because you have to build the runway to do it. It's quite simple, right? When you're looking at how you move things forward, 10,000 iterations or 10,000 trial and error and learnings beats 4 in the real world, right? We're moving to a world where everything is going to be simulated digitally. And what that means is that you have more at-bats per unit time, right? And if you're thinking about launching a great product, launching a great startup, doing great research, building something that's never been done before, this is the key to success. because no one knows how long or how many iterations you need. But if you do more, you're going to win naturally. So that's really one of the keys. So just remember, if you remember anything from today, that's what I think one of the keys is as to why you should go through this trouble. Next slide. Just some stuff about us. Healthcare Partner of the Year with NVIDIA. We work with a lot of institutions to build out specifically things around digital twins, around AI, around centers of excellence. Next slide. Hit one more. If you don't remember anything specifically about this is a look at like our team and how we're constructed. One of the things that I always like to talk about is the different types of people that are required to build a replica of the real world in order to build a foundation for simulation to be able to run all these iterations. There's a lot of studies out there that show, around 10 different types of people are required, from obviously subject matter experts to scientists to developers to data scientists to platform folks. And the key here really, and the organizations that we've seen successful are the organizations that are where folks are comfortable reaching out to people that are not like them are really the keys to success out here, right? I know there's a lot of talk out here around technology or around the science, and that's also, that's really important, but it's much more human than that, I think. You have to be comfortable reaching out to folks that are not like you, that have different skill sets that you don't have. And I think we've been so used to, 10 years ago, if you're an engineer, you only work with engineers, right? If you're involved in the area of science, you only work with those folks, right? But you really need, the key to success is really around building cross-functional teams. And I think we're just a micro example of that over the last 10 years. Next. Oh, one more. So what's digital twin in terms of like definitional wise at least from the NVIDIA perspective? It's a 3D representation of the real world that you can use as a baseline to run simulations of that world. So you can run that many more iterations to better understand how to move forward, right? Obviously, everyone knows NVIDIA as far as like GPUs, but Omniverse is a platform essentially that allows you to centralize, sort of like the GitHub of digital twins, only 2008, as far as the impact GitHub has made on software. The idea is all around community and being able to bring folks together. I don't necessarily talking specifically about it from like a product perspective or an ecosystem perspective, more just philosophically how you actually assemble a team, I think, around both the build and the use side. So next. It's very symbiotic as far as how it works specifically within the AI side. If you're trying to build something to simulate the real world, obviously you start with a 3D model, and AI techniques are making it easier to build that. But then on the flip side, as far as the use side, to be able to put it in the hands of what I call maybe non-domain experts, right? I think everyone here, if you're here by association, is a domain expert, but how do you make it easier for, regular folks and to actually get value out of it and to run these simulations to make better decisions in their life, for their business, for themselves? And that's really an area I think that AI is making it easier and easier to make more accessible. Next. If you look at this, why go through the trouble? Everything out there comes down to one thing. Every business, I think in many ways, our careers, how do you move goods, services, and products and ideas through a process faster than the day before, faster than your competition, whoever that might be? That's like the nutshell of every single thing I think that exists in the world. And to be able to run these simulations to get that many more reps per unit time is the key to success, even if you don't exactly know how you're going to do it. So it's more about building the muscle and the apparatus to be able to do that. And this is, I think, the very, very beginnings of why you should, I think, go through the trouble to actually build a replica of whatever it is you're working on so that you can run this. Obviously, it's a really heavy lift. It takes a lot of time. But those that are able to build the apparatus and the operational muscle people do that, I think are one thing to be successful. Next. So this is the only technology slide I really have. There are a lot of things that have kind of come together to make this point in time possible, ranging from making GPUs accessible from your gaming laptop all the way to supercomputers. Also file formats being open and extensible, specifically Universal Scene Descriptor, which is a file format that was open sourced by Pixar years ago that's embraced by many folks that sort of serve as the hub and your hub spoke if you're trying to build a community around how do you source and build these digital twins and then how do you use it. And then also the tie into robotics, right? Right now we're talking about simulations to make better decisions versus in the physical world. The next step is that you can run simulations and then the world moves around you to make your life better or make the life of the organization better, regardless if you're in a hospital and you have drones and robots moving around, or this building, or schools, whatever that might be, right? It's one thing to run a simulation and then to take an outcome, but imagine if the world moves around you based on what you discovered. And that's essentially where we're moving to these days. Can you roll the video real quick? Sorry, okay, here we go. Okay, so this is an example of early digital twin projects that we were working tightly with the University of Florida on. This is specifically UF Health Shands Hospital in Gainesville, Florida. It's a 50-room build-out and neuro ICU unit that will serve as a foundation for everything from operational, clinical to research work. That's a representation. This was a culmination of 1 year build-out. Everything here is high fidelity. It's physics ready. Really complicated, jargony words to mean that this can represent the real world in combinations that you haven't thought about yet. When you build the foundation and you build it right from the beginning, what that means is that everything there can be used to run a multitude of simulations for lots and lots and lots of different groups and people as time goes on. And, you know, if you see, obviously everything is kind of realistic in how it looks, but everything here can be manipulated and moved, and everyone can make a clone. If you think about 10,000 experiments happening in this hospital all at once, that's what the future looks like. And this is a little glimpse of that. So thank you
so much, Andy. And now we're going to hear from our final panelist. Welcome.
Hey, y'all. I'm Deanne Carlin. Really happy to be with you here today. And I'm going to talk to you a little bit about Southwest Digital Twin. So first of all, I have a question for y'all. How many of you are Southwest Airlines customers? Maybe you've flown us recently. Ooh, I love to see all those customers. Thank y'all for doing that. We know you have other choices, so we really appreciate you choosing Southwest. And for those of you that didn't choose Southwest, I don't know if you guys have heard about this cool new thing we're doing called Assigned Seats, but that's coming in January. It's pretty exciting, so come on board. It'll be fun. All right. So when most people outside the industry see an airplane in the sky, they think about people going from point A to point B, whether they're traveling for work or for leisure, whatever it may be. What people in the industry see is the culmination. Sorry if you can hear this alerting, my insulin pump is going crazy right now. What people in the industry see is the culmination of managing 3 separate networks around a flight schedule. So those networks are aircraft, our frontline workforce, so think crew members, maintenance technicians, ground ops agents above the wing and below the wing, and then, of course, our passengers, the most important network, because our purpose is to connect people to the important things in their lives. So these 3 networks have to work in tandem for every single flight. We can go to the next slide. Do I have the... Oh. Sorry, guys. They work in tandem for every single flight. And for Southwest, that's currently about 4,000 flights per day. During heavy holiday periods, it's up to 4,500 flights a day. And those networks have to withstand shocks and changes. That might be government shutdowns, severe weather, or even a crew member calling in sick. And the goal is to not disrupt the customer journey. That's the operation we manage. And until recently, we were managing those 3 networks in separate silos. Enter Heartbeat, the pulse of the airline. This is a real-time data product that is our digital twin for the state of the airline. So what does this digital twin give us? First is real-time visibility. Heartbeat continually reflects the true state of the operation as events occur. No waiting, no reconciling data between systems, one living view. The other thing it gives us is cross-network intelligence. So every flight, every workforce change, every passenger update, instantly. And all of those events are reshaped into a unified operation model. So we can see how changes or proposed changes will cascade across all 3 networks instantly. And both of those result in decision velocity. In an operation where seconds matter, because of flight delays, because of tight connections, because of recovery events, it's this vision, this unified view that enables us to make faster, better decisions with confidence. So leaders and operational teams can make decisions that we are confident will be what results in the best thing for the customer. What makes Heartbeat especially powerful is its scope. We ingest from over 200 data sources, giving live events. And so that could be anything from operational systems to the Southwest mobile app, to the airport kiosks, to sensors on the aircraft, or many more. And Heartbeat captures those in a unified view. Today, that model feeds real-time decisioning systems and leadership dashboards for situational awareness. Our optimizers use Heartbeat to create solutions for regular operations that factor in impacts to all three networks with human-in-the-loop approval. Southwest is also obsessed with on-time flights, as we should be. And so we're using Heartbeat to visualize real-time readiness at the gate and positioning for ground support equipment like bag tugs, for ramp agents, de-ice pad activity, and more. So stations have the data they need to take fast action to ensure a fast turn. And soon, it's possible that certain decisions, simple decisions, could be made automatically. So think gate changes to improve traffic flow at an airport. And in the near future, Heartbeat could be used predictably to bring efficiencies to things like airport throughput and lobby experience. That's a lot of value, but there's even more possibility. With Heartbeat, Southwest is moving beyond reactive customer care to integration of customers into real-time operations. A few possibilities. Transparency as competitive edge. So customers could receive real-time status updates on things like crew changes or maintenance events that impact their flight, turning potential frustration into trust. Hopefully. Proactive rebooking. When delays occur, because they will inevitably, Heartbeat can identify which customers will not make their connecting flight. And they can do that before the delays propagate. So that means we can automatically rebook a customer on the best viable option with customer notification. And dynamic loyalty engagement. So think real-time offer generation based on operational context, like personalized offers for flight disruptions or priority standby for frequent flyers during irregular operations. Heartbeat is not simply to create a mirror of the operation. It's to enable better, faster, more adaptive decision-making across the entire airline for a better customer experience and for our shareholders. Heartbeat and the amazing people of Southwest Airlines are making this future possible. Thank y'all.
Thank you so much, Deanne. And we have a couple of minutes for questions from the audience. Yes, please. Wait for 1 minute for a microphone, please. Hi, Mike. Can you hear me? Hello? Can you hear me? Wonderful. Thank you. My question's for Deanne. Can you talk a little bit about how the system works with the external factors that Southwest doesn't own? So like the actual airport, air traffic control, your vendors, and how you're able to collaborate with that.
Is this starting? Yeah, so we work with all of our vendors to send real-time eventing. We work with the FAA to do that. Our aircraft sensors, we already get real-time events from those. So ultimately, what this was about was, as you guys know, we had some outdated systems in the past. So it was about rebuilding the infrastructure to get all of this real-time eventing so that we could build this, but also so that we can make all of our systems more reliable and more resilient and all of those things. So yes, we've worked with all of the external partners to do that.
Great. Other questions for the panelists? Yes, please. If you wait 1 second for the microphone.
Let me ask a question while we're waiting on getting.
Sure.
It's a question for Andy. One of the challenges has been simulation has looked cartoonish. It means it's more gamified than reality. But what you're showing is something that's pretty close to reality. How did you build those models? Is that driven off the CAD drawings? Is it video that you incorporate into your model? How do you build those models?
So that was actually the second half of my presentation. Today, unfortunately, to build something really high fidelity, physics ready, you really do that. So we have a pretty strong team of 3D artists that does nothing but this every day. The industry itself is evolving where pretty soon you'll be able to use AI techniques to better create synthetic assets in that world. That's where we're moving to right now, but we're not quite there yet. So I think we're at a really interesting inflection point because once that happens, it'll open up the aperture and it'll democratize this. But right now, quite frankly, only the leaders in each domain are investing heavily in this because it's kind of hard at the beginning. As you can probably see, that took a really long time. But once you have that, you'll have a huge advantage because, I mean, you'll have a digital representation of, your place of work, your building, your facility, and everyone will have to catch up. So, it's an interesting time. And then robotics is the next phase. I build it on top of that. They can simulate on top. So it's like building a house, right? Start with the foundation. That's the foundation.
Great. And I think we have time for your last question, please.
My question is for Mr. Lin. So I've been following the change logs for Omniverse, and we now have 3 different rendering engines. We have the RTX 2.0, we have the Iris, and then now we have the scientific visualization. So my question for you is, which engine was used for the hospital visualization? And then also, how did you decide between all of these engines, which suited your needs?
That's a really good question. You're really into this. We should talk after this. I've actually got a couple folks. I actually don't know the answer to your question specifically on which we used. I mean, I could tell you the architecture. I mean, obviously we use Nucleus, and then, Maya and Adobe Substance 3D are primarily our tools that we use to actually illustrate and build that. We primarily have built this all off visual identification. So we have somebody who just looks at these pictures and then builds them all, specifically in the lab that I showed really quickly. But I'd be happy to talk to you after, maybe connect you to some folks on our team. So good question.
Thank you all for being such wonderful audience members. And also, please thank the panelists with me. And now it's time for a break.
Thanks.